Okay, so basically the thing that we're kind of like changing up with, we're still solving inequalities, but what's different now is that we're trying to solve inequalities that have variable terms on both sides. So when you were supposed to study this front side of the note yesterday, it was already completed for you. And what does it say? When the variables on both sides, collect them what? On one side or the other. So are you necessarily going to make the same first move solving a problem like this as everybody else in the classroom? So do we have choices?
Yes.
So what's one of the choices that we could do with this problem here? If I wanted to solve that, what's one of the first moves I could make? There are options. So what would it be? What did the completed notes do? What was their first move?
Add the 2x.
Add 2x to both sides?
Yeah.
Okay. So why do we add 2x to both sides in that one? Why would that one be an add 2x?
Because you would not want 5x and 2x. 2x's on either side.
Okay, we got x's on both sides, so we got to get rid of them on one side or the other.
Yeah.
So if we want to get rid of them on the right side, we would add 2x to our negative 2x because they're opposites of each other. What happens when you add opposites? What do you get? What should you get if you have two opposites? So you add an opposite to its opposite. Give me an example of an opposite and some opposites.
Negative 3 and 3.
Negative 3 and 3. What happens when you add negative 3 and 3? You get 0. So when you add opposites, so that's what happens. Negative 2x plus 2x, negative 2 and positive 2 are opposites, so then those x's become 0 x's. They're gone. 0 times x is 0. So we get rid of them on that side. Could we instead have, instead of what they did in the notes yesterday, could we instead have gotten rid of the 5x on the left side?
No,
Why not?
because then it would not make sense.
Why not?
Because it would probably be like a fraction or something.
We should get the same answer no matter which move we make first. So you don't have to necessarily do this on your notes unless you want to do it off to the side. We could solve this by getting rid of the 5x first. What would I do to get the 5x? Instead of working with the negative 2x, I want to work with this. I want to get this off of this. We'd have to subtract 5x from both sides. So what would be left over here? 1. And what's a negative 2x take away 5 more x's?
Negative 7.
Negative 7x and minus 6. Is there anything wrong with that? No. And now we would do what? Add the opposite of what? So we'd add 6 to both sides. Okay. Add 6 to both sides. 1 plus 6 is 7. Some of you are not engaged and you need to engage right now. Is less than? What's left on the other side? Negative 7x. Okay.
You divide the negative 7.
Now we divide both sides by negative 7. What is 7 divided by negative 7?
1.
Negative 1.
And then we switch the sign.
Got to switch the sign because we divided by a negative. And now we have just x over here.
And just switch the x and then negative 1.
And then we could let the negative 1 and the x switch sides, so x could be over on the left where we kind of like it. And so we have to switch the inequality symbol also. And is that the solution that the completed notes had for you when they worked with the negative 2x instead? Yeah. So it doesn't matter which set of x's you decide to move. We did this back when we were doing equations. We said some of us will make a different first move than others will make. But we all need to end up with the same solution in the end. So there are different ways we can go about it, but there are some different ways we can go about it that would be incorrect also. We just got to make sure that we know what we're doing. Okay, this next one, number 2. Remember back to equations. When we had variables on both sides, and one of the sides did not have anything with the variable term, nothing was being added or subtracted with that variable term, such as right here, our 4a. Nothing is over there with that 4a. Would we want to move the 4a? What should we move instead? The 7a. Now, if you choose to move the 4a, it's not like it's a wrong move. it's probably just not as good of a move as you could have made. But if you choose to move the 4A, we would subtract 4A from both sides. What happens over on this side? There's nothing left. Does that mean we just let something else come over there? What is 4A subtract 4A?
0.
0. So we would put a 0 here. And then we would keep going. We could, there's nothing wrong with this. 0 is a legitimate number. So if you choose to move the one that doesn't have anything else over there with it, you got to put a 0 there then after you get rid of it. So keep that in mind, that when there's nothing with the variable term, that might be the one you want to leave alone, and you might want to get rid of the other one instead, okay? Okay, let's go to the back side, what we're really going to add to it today. Today you have to set up your own inequalities sometimes and solve them, just like we were doing on the front side. So here's our, let's put a box around this. Here's our problem right here. You box that, make it stand out on your papers. Would you put a box around that? Circle it with something, whatever, shape you want. If you had a choice between 2 ski ticket plans, how could you determine the number of days for which plan A costs less than plan B? And it says above, create an inequality to solve this. So the problem-solving method we're going to use is creating an inequality to help us solve it. So here's our information. Plan A costs $45 a day and includes the lift ticket and equipment. So in other words, for $45, you can go to this place and you can ski for the day, get everything you need. The lift ticket to get your rides on the ski lift, the equipment to do the skiing with, the right to be on their slopes. Plan B costs $350 for the whole season, so several days. But you only pay it one time, and includes the equipment. So you pay for the season pass, you have the rights to come and ski there, and they'll give you the equipment to ski with every time you come. But they don't provide, this $350 does not provide the $20 lift ticket each day. So every time you come, you have to buy the lift ticket, or you got to walk back up the mountain every time, or the slope, okay? So in this problem, we have to decide what X is going to represent. So kind of like, what's the thing that can change? What's the unknown? So anybody know what we would call the unknown in this? What could X be? If you had a choice between 2 ski ticket plans, how could you determine the number of days for which the plan A costs less than plan B? Anybody have an answer for me?
X represents the number of days.
Yeah. When we're trying to decide what the variable should represent, look at the question that was asking, or what they're asking you to do. It says determine the number of days. Right there, it says determine the number of days. So that's your hint right there that that's what we need X to represent. So let's write that here, represent number of days. So when you're setting up your own inequalities today, you have to do, this is your first move. What variable am I going to use, and what does it represent? You have to write it out. So let X represent the number of days. I guess I should have a thumb there. With X being standing for the number of days, now we're going to write an algebraic expression that would represent how much it would cost you if you went skiing using plan A. So plan A is $45 a day and includes the lift ticket and equipment. So how could you figure out how much it would cost you to use plan A? What expression could we use? An expression is something like this, 3x plus 1. That's an expression.
So 45x.
Okay.
Wait.
Let's write and see what it looks like. $45 X. So this says 45 times the number of days. Would that tell you how much it would cost you to use plan A? Okay, do we have to add anything to it? No, because remember, this is the one that includes everything, right? Okay, how about Plan B? What do you think, what expression could we use that would represent Plan B? Plan B costs $350 for the season, which includes the equipment, but not the $20 lift ticket each day. Blake?
350X plus
350X plus 20. Okay, I'm going to write it, and then we're going to evaluate it. What do we think? 350 times the number of days, plus you pay $20 one time, it sounds like.
No.
No, it'd be 350 plus 20.
So the 20 is what should be getting multiplied by the X, shouldn't it? Yeah, it's $20 a day. So we don't want the X on the 350. Definitely, I don't think I'd ever want to go skiing there if it was $350 a day. $350 is the season pass that gives you all the equipment and the rights to go skiing there, and then it's $20 every day for the ski lift ticket. Okay, now it also said, now we're going to go back to what we were asked, determine the number of days for which Plan A costs less than Plan B. So let's put that in words first. Plan A needs to be less than Plan B. Let's write it in words first. Then we'll substitute in our algebraic expressions. So Plan A is less than Plan B. That's what they wanted us to determine. How many days can you go skiing? And Plan A will still cost you less than Plan B. Okay, so we'll substitute 45X for the Plan A, because that's what we said Plan A is. We'll substitute 350 plus 20X for Plan B. And now we'll solve our inequality that has variable terms on it. What do you think we should make our first move?
Minus 20X.
Anybody want to agree with that? Do you think that's a good move? Subtract 20X? Yeah? Okay. Let's go with it then. Subtract 20X from both sides. Because we got to have X's on both sides. We got to get rid of them on one side or the other. After we subtract that 20X, what do we have on the left side?
25.
25X. Do we need to do anything with the symbol? Did we do any multiplying or dividing yet?
No.
No. And what's left on the right side? What do we have? 350. Okay. Trust me, you guys really don't need to calculate this. I know you can do this without it. Let's try. Come on, get those fingers on that calculator, your mushy brains. What are we going to do first, though, to get the X alone?
Divide 25 on both sides.
We're going to divide both sides by 25. You can do this without a calculator. We have 350. Well, how many 25s are in 100?
4.
4. Well, we got 300 though. So 4 and 4 is,
42.
and what do you just stick with the way I'm going through here?
8.
4 and 100, another 4 for 200, another 4 for 300. How many we up to? 4,
12.
4, 4. We got 12 so far. Now how many are in 50? 2. 12 plus 2 is 14. You guys, you need to make yourself do that exercise. Don't let that calculator just spit it out for
I
you.
did in my head, I got 15.
And you got 15? Well, you were close, weren't you? Okay, so it's 14, isn't it?
Oh, because I went 20 into 100, not 25 into 100.
Okay, there you go. Okay, so this says X is less than 14. Now remember what we do with word problems. We write a sentence answer. So first of all, let's graph that. We got 14, integer neighbors. Do we fill in our circle at 14?
No.
Okay, 14 doesn't count. Okay. Now, when I look at that graph, and since I know that X is representing days, X is representing days, what's happening on that graph? What would, like right here, halfway between 13 and 14, what's that?
13 and a half.
13 and a half. Do you think you can go to the ski lift and say, because you didn't get there till 2 o'clock in the afternoon, you can be, can I have a half a day? Can I pay for a half a day? Did it say that they allowed that? No. So it's only full days, right? Can you have negative days? No. Would this eventually get into negative territory going this way? Yeah, this is eventually going to end up in negative territory since it's going to the left. So we have to state the restrictions where X is a whole number. And that's the only way we have to say it. Because whole numbers stop at what? Does anybody know where whole numbers stop at? 0. So there are no negative numbers when you talk about the whole numbers. So we need whole number days, and because we're calling them whole numbers don't go into negative territory, so we're okay. Now we have to write our sentence answer. If what? Or let's not start with if. I don't like it starting with an if. Let's try that. Let's change that. Let's go to something else. Plan A, they want to know when Plan A costs less. So what are we going to say? Plan A costs less than Plan B. That's what they wanted to know. And that's how we set it up. Now the if. If what? What does that graph show us? What does that inequality show us? Plan A costs less than Plan B if? Don't worry about the whole number thing right now. Just talk about when will Plan A cost less than Plan B. Okay. Something about 14 days, yeah?
If they're in 14 days, or it's already been 15 days?
No.
14 days in there?
So,
If you go over.
Wait, if it's less than 14 days.
oh, yeah. So Plan A costs less than Plan B if you go skiing less than 14 days. When do you think they cost the same? Do you think the cost would be the same at whichever one you went? And which date? 14 days. That 14 days is when they're exactly the same. But if you go less than 14 days, it'll be less money if you go with Plan A. If you're an avid, love to ski, and you're going to go more than 14 days, then go with Plan B. Okay, so on these, what do? We start by picking a variable and describing it. We set up an inequality and notice the kinds of steps we use to help ourselves be successful, setting up an inequality. We wrote some expressions that represented the situation. We said, what do they want? Then we wrote our inequality statement. Then we solved it. After we got done solving it, we graphed it. After we graphed it, we said, are there any restrictions? This is called a restriction. And then after that, we wrote our sentence answer. Okay? So in problems like this in the homework, when you have these word problems, make sure you follow all of those things. Make sure that yours includes that. So it isn't just something just to get it done and not really understand what you're doing. Any questions? Okay, then let's get to work on your homework. Sydney, sit up. I think that'll help.